להתחיל? Okay. So this is English. Cool. Okay, so welcome everybody to, I guess, the last session of the day. So thank you for those who stuck around. This talk is going to be very different than the previous one. So I think together you'll get a good mix of some of the core underlying techniques and some interesting use cases of NLP. So first of all, my talk originally was Advancing Trusting and Scaling AI. I will say something about it, but because I'm in the NLP track and we do a lot of work, I thought it would be more relevant to focus on the NLP work. So most of the talk will focus on specifically what we are doing in IBM Research in the area that we call mastering language, which is basically, I would say, NLP++, and some of its applications. But I do want to start for a minute with this idea and why, what are some of the issues of deploying AI and then language in general in enterprises, and put that in context of also the work that we do for NLP. So clearly we're in AI Week. What an amazing conference. So many people, so many companies. We know AI is everywhere, and we all use AI every day. Not only do we use it in a lot of consumer applications, we know, and we see more and more deployment of AI in industry challenges. And we have many companies, fortunately in Israel, doing many of these use cases, developing technology and so on. But still, if we kind of look at how wide is AI really deployed in what we will call enterprises, our traditional customers, the companies, the large companies that are the biggest application builders, whether it's banks or insurance companies, not necessarily a startup that can afford to have a few experts, or even a company that is focusing in an area. Really, people who want to come and use, as we just saw, Spark NLP or something like that in general, we find out that it is not as widely deployed as one would think. And the reasons are, vary, and there are, it turns out, a lot of challenges that industry has today in order to really apply AI in the real world, not packaged as something that somebody else already built an application for you. I was in the morning in Shai Manor's talk on reinforcement learning. I was very happy to hear a professor from the university whose whole career is based on reinforcement learning say that, it's not really ready for real use cases because of some of these things that at the end of the day are very important once you come and apply AI in an enterprise scenario. And some of these are listed here. One of them is a problem that many companies have. Most of the great AI algorithms are built by having a lot of data, and not only a lot of data, a lot of annotated data. And the question of what can we do if we're not so lucky to have so much data, and what are some of the techniques that we can use to learn from less data or less labeled data are key in order to be able to deploy and do customization, as even maybe the last question was alluding to. What do I need to bring to the table to make this work for my data? Issues around explainability and fairness are critical. People need to trust the system and trust the AI before they start using it. Systems that are totally black boxes are typically problematic, but on the other hand, we can't really build rule-based systems. It's not scalable and so on. So something that somehow still uses all the latest AI techniques and so on, however, is able to provide some explainability is required. The whole notion of fairness and is my algorithm biased and so on is also critical. AI lifecycle, Shai again mentioned this in the morning. There is really not a good discipline yet out there of what does it mean to develop, test, deploy, debug a AI system and keep it up and running over time. And it is required, right? Because you could do an amazing job of training your models on the data you had. However, in practice, your real data is not the same distribution as the data that you trained on, or maybe it started that way, but it changes. And all the software practices that we have for developing software and testing software that were developed over, I don't know, 20, 30 plus years of software engineering research and development need to be developed to really have a healthy AI life cycle that starts from training but doesn't end there and really has to go through everything and keep continuously updating and learning. This also brings in all the issues of security in AI, which adds another layer on top of the already complicated security in code to begin with. And then there are these issues of really how can we start embedding knowledge? As much as we want to believe we can learn everything from examples, we know that people learn from a combination of knowledge that we are either, some claim, born with a little bit, but definitely acquire over the years. And some learn from a lot of examples. And in the area of AI today, because of the big success of deep learning over the last few years, the predominant method that is used is more this implicit learning, and how do you now combine the two? And finally, the topic that I will talk about today is the one area that on the one hand has many, many use cases. The amount of unstructured data in enterprises is by far larger than anything else. However, to date, the technology has not been good enough, and we don't yet have conversational systems, which we're going to talk about, that can really understand and converse with humans. So these are the AI challenges, and not surprisingly, IBM Research AI, we are a worldwide organization. We have a few hundred researchers across the world. In terms of our agenda, we have organized our agenda worldwide to tackle these problems, because at the end we're like an enterprise company, so for us AI for the enterprise is our goal. And we do have projects that cover these areas that I just described, a lot of work on trusting AI, fairness, explainability, transparency, and so on, life cycle management. Some of this is already translated into some IBM products, which I'm not here to sell, but there are now products that are starting to show up there. IBM OpenScale, as an example, just so people want to get a sense of what are the types of tools that companies now look for to use that do provide them some of these abilities to, for example, detect drift over time, detect if algorithms are biased, correct bias, and things like that. And then in terms of advancing AI for the enterprise, really our two main focus areas are around this whole area of understanding language, which we're going to talk about, and this whole idea of neurosymbolic AI, which I'm not going to talk about, but is, again, an area we're now investing heavily to really see whether we can combine these two disciplines in a modern way, right? So take kind of the AI of the past, symbolic AI, and bring it together with deep learned AI, and how can we then use this to combine knowledge and learning to do interesting things. So in this particular track, I do not have to pitch this slide, obviously. We all know that language is, on the one hand, the way we communicate, right? It's the way people communicate. So we do aspire to get to the point that machines and humans can communicate in the language of humans. That is what we need, again, to get AI deployed widely. And that is what we want our systems as they become more and more intelligent to do. However, language is not easy. It is different in different languages, a lot of ambiguity and so on. And anyone who works in this area, and I'm assuming people here know this, understand that. We call this area for us mastering language. It's kind of trying to capture that this is beyond, just natural language processing or natural language understanding, but really getting to the point that a machine can master language in the same way that a person does, starting from childhood, learning, first elements of language, and then being able to handle some of these more complicated tasks. And within this agenda, we are focusing on 4 specific things. The first one is is on the basics, right? So I think, similar to what Spark NLP is doing, there is work that we are doing on the core language modeling. One of the things that we really have to worry about is multilingual. IBM is a company that works in 300 countries around the world, has to work in every single language. We can't afford to have to do every language separately. So how do you do a lot of more things multilingual? You train in one language, are able to do them in other languages, and many more things kind of more on the core underlying language model. And then we have three main focuses, thrusts. So computational argumentation. Noam was here in the morning. He gave a talk about Project Debater. And that is the discipline of Project Debater is what's called computational argumentation. And really, the debate system was there to advance the state of the art of the core technology, and we are now looking at different deployments of this technology. And then question answering is another one. I will talk about that very briefly. And conversational assistance is a big part of our agenda, and where I'm going to focus most of the rest of the talk. So just before, I want to say something about question answering. So question answering, as people know, has also, even though one would argue this has been around, the problem that's been around for a long time, and even the IBM Jeopardy system, Watson in 2011, seemed to show that it's a solved problem, but it's not, right? So what happened afterwards is, even though we built an amazing system that beat people in Jeopardy, it turns out that taking that same system and really being able to load it with any data set and being able to answer questions is not an easy task. And this has recently become a very hot topic and a very powerful way to advance core NLP, and BERT and GLOVE and all these technologies in part come out of question answering. But it turns out that if we when we look at the real use cases, these are typically, all these benchmarks, squad, natural questions, and so on are typically done on open data sets, on data that is not easy, but has some properties that help it. The real world, and in particular the use cases that we look at, which are around technical support, customer support, are much, much more difficult, and again suffer from this problem that you don't really have a lot of data to learn from. In order to really open up the minds of other researchers and be able to really pose a new problem out there to the world, we have just recently announced at AM NLP last week a new data set and a leaderboard focusing specifically on this use case of question answering for tech support. And the difference is that, first of all, these are typically much longer questions and answers than the current leaderboard. These are much more complicated questions, I would say. The other difference is that there isn't a lot of training data. So we put out there 600 question answer pairs, and which is realistic. I mean, even to get that was not easy. This was built on our forums coming to IBM data, but getting a robust data set that's labeled and everything. And the theory and the hypothesis is that at the end of the day, this is a transfer learning, domain adaptation thing. So we want to be able to take all the great work that has been developed in areas where there is a lot of training data and see how could one adopt that to a use case where you don't have a lot of data, which, as we said, is the more typical use case that we see in the world. So what we want to get through this Tech QA data set and leaderboard is really to get more people in the research community to start working on such problems. And here you have also the URL as well as barcode that you could go, but just type, Tech QA leaderboard, I think on Google, you'll already get there. We are obviously also developing our own technology to do this. The first two entries in this leaderboard come from two teams in IBM Research who have done what I said before. These are teams that have been competing on Squad, on natural questions, on Hotpot QA, and they took their best running, and they are atop of those leaderboards now. And they took their best code and ran it, adopted it, and you can see we're starting from about 53% F1, so a lot of room for improvement for everybody to go and really try to tackle this problem out there. And we will of course continue to do it ourselves internally and with our IBM products in this area. Okay, so as I said, the rest I'm going to focus predominantly on the work that we're doing in the area of customer care. And why customer care, don't need to elaborate too much. At the end of the day, this is one of the critical things for most companies. A customer that is not happy with the care they get is likely to not come back to that company. On the other hand, customers who are delighted will be happy and recommend to their friends and so on. Now, fortunately, we are in an area that, again, has a lot of innovation. Many companies are deploying chatbots. There are a lot of things out there. There are many different products. Product in IBM is a product called Watson Assistant, which is a product that helps companies, helps organizations build virtual assistants for their organizations. And you can see just from the list of, this is how we advertise our product, the types of challenges that we have and what are some of the issues that I will talk about. And fortunately for us, again, this is widely deployed. We have many customers, which means a lot of usage and an area that we can then apply our innovation in the context of real-world use cases and data in customers. So what are the challenges and why is this, in my opinion, a very, very interesting, fascinating area to work on in NLP and AI? So we've basically, traditionally we had the customers and we had the agents, and now we are building a new ecosystem which has all three of them. Okay, so it's not like the bots are somehow replacing the agents altogether. This new ecosystem will typically have all three of them. We're going to have the customer, obviously, that has their issues. The customer can come through multiple channels. We see this ecosystem here a little bit, and I'll show you how this leads to our research agenda. Right, so the customer can come through multiple channels. Ideally, we want to be able to serve the customer through self-help. This depends on what they want to do. It could be a conversation, or it could be a question answer, to a question answering system. It could be a search. So we really need to understand what the problem is and what is the best way to serve the user. If that doesn't work, if there is no good answer, or if our conversation is going nowhere, what the customers expect is to be automatically transferred to a human person. They also expect that human person to not come in cold. So you really want this human person to know everything that happened before, and then you want the technology to help the human as well, right? So we really have this triangle, and we want to have technology help in all these different areas. So this is kind of what happens at runtime when you get a question. The other big challenge in this area, if you come to a company and you tell them, look, I'm going to help you automate your call center. Great, lovely. They all want to do it. Is one of their biggest expenses. But how much will it cost me to do that, right? This is the other question. And it turns out that with all the systems out there today, this is true for our system and it's true for every other system, this whole idea of bootstrapping is not trivial. So this is very good for the other side of IBM, where we sell services, and Accenture and all these other companies that come and help companies build these things. But it's not good because most companies want to be able to launch this on their own and so on. So from our perspective, every challenge out there is a big research opportunity, and therefore a big part of our agenda is really around this whole idea of bootstrapping. How do you bootstrap, and how do you continuously learn? So given, again, the state of the art, where we are with customers, what are one of these challenges, their challenges, these are the 6 things that we're focusing on, and I'm going to give you, for each one of them, a little bit of a taste of the research that we're doing and some of the results. So we talked about bootstrapping, we talked about continuous learning, we talked about handover. Extracting insights I'm not going to talk about today. It is an interesting issue too. Once you start collecting all these conversations, an organization says now, okay, what can I learn? I want to learn about my products. Maybe there's a new product opportunity. Maybe I have a new problem with a product I never heard about. So there's also a lot of desire to extract useful information from these. And the other interesting thing that happened here is because these are not only chatbots, more and more of these systems are voice systems. The whole question of how do you combine your speech technology with your NLP technology and your conversational technology has become a very important topic for us as well. So let's talk about bootstrapping for now. So the problems is that humans, the way I don't know if everybody here is familiar with how these systems work. It is, unfortunately, much dumber than maybe one would think. But the way generally all these systems, doesn't matter if it's IBM, Dialogflow, all these systems work, Microsoft, is an intent comes in, some AI or a classifier runs, you decide, what this intent is, and then you start going through a very, very intricate tree. Basically a flow chart, more or less like a dialogue tree, a dialogue flow, which will then try to resolve that based on the classifier and based on this dialogue, this tree, and so on. And our goal really is to get to the point that we can, with minimum time, get to maximum accuracy. And the state of the art today is that in order to get to a very, very good machine, a very good system that will be able to satisfy your customer needs, you need to invest a lot of time. So our goal is really how do we help in, and not only that, the other thing is you want it to be able to do it with SMEs, like with subject matter experts and not with programmers. You don't really, or ideally you come to a company and they say, oh, I have many call center agents. I have a lot of people who know how to answer questions and how I teach my operators. I want them to train your system. I don't want, and we call this persona Tanya for some reason. Tanya is our trainer. So we really want to make Tanya's life easier. We want it to get quicker and so on. And this is a tip of a lot of different things that we do, but I'll just describe one of the things we do. So the big idea is that, okay, you come into organization. Until now, you already had a call center, and as we know, when we call the call centers, our calls are recorded, so you probably have a lot of recordings. So can we use those recordings to bootstrap? Really, can we just start with that and use those recordings to extract what are people asking and help you build this system? And then the next one is that you want to be able to do this on an ongoing basis as the agent, the chatbot virtual agent works, to see what are some of the gaps and how can you continuously build a richer and richer set of intents and then the tree to solve them. So one of the things that we do in this system, it really has an intricate toolkit that can recommend a lot of things called Watson Recommends, but one of them is recommending new intents. So the idea here is you look at all these logs, and you already have, the assumption is that you already have something. You have a classifier, and now you want to really figure out, using active learning type techniques, where do you have holes and what should you label and how much effort should you put into it. So we first filter and say, okay, these things are working fine. These things, seem to not, we don't have good confidence for them. They seem to be worth labeling. After we find the ones that, based on the classifier confidence we think are not good enough, we will cluster them because you can't really have single intents. You want to find all the different ways somebody's saying, my bill is wrong, I don't know, whatever, what's the weather? So we cluster them. And then we want to give them a title and also rank them in priority order. And again, behind the scenes, we're using a lot of techniques here from curriculum clustering, active learning, and so on to pick this and then to rank and to give them titles. And then now we have a list of things, title and rank, and we need to see what are we going to do with them. And how is it going to affect the overall performance? Because you may add things that actually will maybe help in one place, but actually be a problem in another place. So really the only way, and especially since this is an active learning system, you want to have Humanintheloop at first. So you will have a person look at our linked, our labels and our clustered rank system and really label them and say, okay, these don't make sense to me. These are the ones I'm going to label, append them to the training data, retrain my classifier, evaluate them on the test set to see whether it really improved my overall, or maybe it hurt and impacted negatively something else, and do it again. Now I'm going to run through the system again, find clusters, and so on and so forth, until I decide that I've improved my system and I'm ready to eventually provide these recommendations. Now this is nice, but we don't really necessarily have this person always in the loop. So to do that, we developed, after working and kind of learning from what works and what doesn't, an effort simulator that will automatically pick which ones are worth labeling and feed them back in and run this a few times until we decide that there's no use in running this anymore in terms of the increase in accuracy that we're getting from the system. Okay. Now this is how it looks like. At the end of the day, the user will get these intent recommendations. They will be clustered like we see here. And these are gaps that we think you have in your system. For example, hey, help pay a bill. And then for help pay a bill, we're going to give you a list of intents that you can choose and so on. And that's how we will eventually now improve the real system with Trainer. We are now working on using natural language generation to also maybe create these intents. The ones we see here are ones that we actually pulled from the logs, but we can think of how we could generate these automatically. And this is some new work that we're doing right now. So this is bootstrapping. We talked now about continuously learning and improving the system, right? So this system is up and running. And one of the projects, again, that we did in this area, among many, is this question of how can we evaluate, how good is my agent? And, to do this, we developed something called, detecting egregious conversations. And there's, a lot of details here in terms of what features we used and so on, but I would say what's interesting is what we found is that really a combination of some features that are trivial and everybody uses, how many turns and how much time, and can I talk to an agent, but combining that with some features around emotion and how it's changing over time, and also the likelihood that the agent actually has a good answer, we're able to significantly improve our ability to detect these languages, these conversations by 20% compared to using, just simple features. So this is another interesting piece of work. Handover on bot failure. Okay, so this is typically what we see. Like many other systems, we have the short tail. These are repetitive questions. These are the ones that the conversation system is going to handle well. It's easy to build intents for them. It's easy to predict them. They're going to repeat many times. But most of the queries that come to the system are more in this long tail, not seen many times. How do I handle that? And how do I not get to, I think what's very annoying that most of the personal virtual agents, do today, which is just send you to a search and maybe it's good, maybe it's bad. So we've been working in this area of query prediction performance for many, many years, and really applying this technology now to at the point of realizing that there is no good classification for what the user just said. We will use this query prediction predictor to predict whether my corpus has an answer to it, and whether, once I get the answers, are these good answers. And here, this is kind of the high level of how it works. If it's a good answer, we'll just return it back to the user. If it's not a good answer, we're going to give it to the human agent. And in this sense, we've enabled a good experience for the customer who will either get a good answer from the search system or will be handed over to the agent. And here we see different techniques that we've used, and that they are indeed giving us good work. And you can see the paper here. Now, once that happens, let's say that we did default to the search system, another interesting problem that we tackled was we don't really just want to send the last utterance, right? So the scenario is that the person has just had a conversation with a bot, maybe 3, 4, 5 turns. Can we use that whole conversation as a query to the system? And whether using that whole conversation is indeed going to improve our overall results. And this, by the way, holds both for the system is going to return the results or for the agent. So it could be that we're now using this to help the agent recommend to them what a good result could be, or it could be that we're confident enough to automatically reply this. And so we've really developed a system now that can take a whole dialogue as a query to the search engine. And what we see, I would say as expected, but it's nice to see very nice results, is that indeed the more context we have, the more we're able to improve various measures of accuracy in this system. We've also been looking like, everybody else, okay, BERT's out there. Can we take this now and really use it to improve search results? In this case, we've trained it on, the idea is that, you're going to do your regular search, you're going to get whatever, 50, 100 search results, and now you want to re-rank them. Typically, this is done with learning to rank, and now we're looking to do this, again, using BERT. And the way we did it is we trained it, the positive examples were queries and good passages, and the negative are queries and passages that are random and most likely not good. Using that, we are able to fine-tune BERT to the specific use case. And indeed, so far, we've run this on some of our test data sets from the customer's data, and we see a very nice improvement, on average 30%. Some cases, it's even much more. Unfortunately, right now, we've not been able to deploy this in practice because the resources are too large, right? If you're going to deploy this, you still need to put too many resources relative to what customers are willing to invest in this. However, we and many others out there are working on compressing BERT and on getting it to run with smaller memory and compute requirements. So I do believe that this will eventually be something that we can also deploy in real use cases. Another very interesting use case that we've been working on recently, some of these queries, really the answers are in tables. So a lot of times the customer support is some form of tech support. We work with companies like Siemens, like Honda, and so on, and they have manuals. People come and want to search on those manuals. So can we use tables really how can we return results that are tables? And usually it's even good enough. We want to get to the next point, maybe question answer out of these, but even we find that just returning the table, even if it's on a phone or part of your conversation is pretty useful. So this is another research project we've been working on. Some of the challenges here are, first of all, you want to expand. You don't want to, you want to have some semantic knowledge on your domain being used, so you're not just looking for the keywords in these tables. And then how do you rank the tables? And we've been applying both classic IR techniques and also some interesting deep learning techniques. And in both cases, we see that we are, when applying these to standard benchmarks out there, we are able to significantly improve state of the art on these benchmarks. And in parallel, we are applying these to some of the customer data sets and seeing pretty good results. It's much harder for us to measure. So this is why we also like using all these standard benchmarks. In addition to being able to publish papers, it gives us some qualitative results. And then we apply it more on some of our customer use cases. It's more a little bit of a qualitative because we don't necessarily have the ground truth for them. So the last thing I'm just going to mention is some of the work we're doing on improving the voice interaction. And this shows us another really important aspect in working with companies. The speaker, David, right before me, alluded to this, right? This whole idea of customization. At the end of the day, you come into a company and you need to work on their data set, also in the voice channel. So there's two parts to it in the voice channel. One is now our bot is speaking. And it turns out that companies, maybe not surprisingly, place a lot of importance on the voice of their bot. I mean, this thing becomes, I talked to some customers, this thing becomes a person. Whether it's internal to the company or internal, they give it a name. Usually it's a female name for some reason. And then they want her to have their own unique voice. It's almost their brand. They don't want their virtual agent to sound like an Alexa or a Siri or whatever we have on our phones. They want to have their own unique voice to it. It gives them a personality, gives it trust, it gives them. So we have been working on a few things. The other thing is they want their bot obviously to be more emotional, and there are a lot of studies that show how the importance of how things are said, the impact of how things are said on customer satisfaction. So we work in this area, and the other area is more really back to domain vocabulary and how can we over time customize to the customer's vocabulary easily. So on the TTS side, we have a few areas that we're focusing on. First thing is just being expressive.
This is a non-smoking car. We apologize for any inconvenience.
So this is just, plain old TTS.
This is a non-smoking car. We apologize for any inconvenience.
So here you can see that we've turned it to more expressive.
This is a non-smoking car. We apologize for any inconvenience.
And this is fast, which I have to say, when the researchers did it, it sounded, okay, that's interesting. I can see why, but I'm not sure. And I was just talking to a customer last week, and he told me, look, the feature I really, really want is to set the pace. Because people in the South, they speak slow, and I want the agent to be much slower. And the people in the north of the United States, they speak really fast. I need it to be much faster. So this ability to now fine-tune programmatically, basically, the API is something
We're sorry to report that Louisiana is in deep budget gumbo again.
So this is now showing emotions. This is, again, our typical non-emotional.
We're sorry to report that Louisiana is in deep budget gumbo again.
So here you can pick emotional, or apologetic, or excited, and different types of emotion. And again, it adapts by itself. And the last one is this.
She can scoop these things into 3 red bags, and we will go meet her Wednesday at the train station. If you would like to be assisted by a member of our customer service department, press 3 to speak to the next available representative.
So here I'm not sure the animation is working right, so let me start again.
If you would like to be assisted by a member of our customer service department, press 3 to speak to the next available representative.
Okay, so this is kind of the original. And
If you would like to be assisted by a member of our customer service department, press 3 to speak to the next available representative.
okay, so here is the target voice. So I started with my basic voice, and I get a target voice, and you can see basically that with 20 minutes of training, we get something that it sounds really, whoops, we're not going to get it.
If you would like to be assisted by a member of our customer service department, press 3 to speak to the next available representative.
Okay, so with only 20 minutes of training, we're able to get the out-of-box to sound, pretty much like the target voice. And even with 5 minutes of training, it's not going to be as smooth, but it still, picks up most of the sound that
If you would like to be assisted by a member of our customer service department, press 3 to speak to the next available representative.
If you would like to be assisted,
Okay, and finally, again, this is just going to show us how we are customizing the speech-to-text for this particular company. I think we can skip that. So just to conclude on this area of AI customer care, I think it's really exciting, a lot of research work. Just from a business perspective, our goal is really for companies to be able to respond faster, more accurate, with less effort in deploying this. We need the customers to be happy and feel comfortable, which is some way to go. We want to help the agents, and we need this bot to be as smart as the people and continue to learn and be able to improve itself. A lot of interesting research work, and hopefully will inspire some other people to work in this area as well. Okay, thank you.